All right, so this is day number 2 of our limits unit. And let's jump right into this first problem here. The limit is the intended value of a function. And in this first one, we're taking the limit as x approaches -1 of h of x times g of x. And just like yesterday where we did a sum problem with these products, what we can say is the limit as x approaches -1 of h of x times the limit as x approaches -1 of f of x is equal to the original. So we're just going to look at them individually. The first part, look on your graph for h, and can you evaluate the limit as x approaches -1? Again, this is what it's intending towards. It may never actually hit it, but as x is approaching -1 from the left and from the right, what is that limit going to be equal to? 2. The y value is going towards 2. Times, then look on the f graph. On the f graph, as the x values are approaching -1, what are the y values approaching? 4. So our limit is 2 times 4, which would be 8. So again, it's kind of straightforward on these problems. There are a few small little wrinkles we'll see as we get into some of these problems, but pretty much the limit of one times the limit of the other. Now let's look at a function composition. Here is the limit that we are trying to evaluate. Give you a chance to look at it. We go from the inside out. So in this first one, the limit is x approaches 0 of the inside h of x. So look on the h graph, and as x is approaching 0, what are the y values approaching? Well, from the left, what are the y values approaching? 1. And from the right, what are the y values approaching? So for the two-sided limit, what is the limit approaching? It doesn't exist, right? And so I'm trying to do like an f of does not exist. This is going to be a DNE. We'll see eventually, like I'll show you like a couple where DNE actually ends up in an answer where part of it does not exist, but we'll see how that can eventually get to like a real answer. All right, next one down. I think this one is a little bit more straightforward. Go ahead and read through this one. So the limit as x approaches -2 of f of h of x. So go to the inside one first. On the h graph, as x is approaching -2, what is the limit? Go ahead and turn to your friend, answer that question. What is that limit going to be? So is it approaching 1? Right? And now, like because this inner part is 1, that we're kind of like changing the problem now, saying the limit as x approaches 1, like that value, as x is approaching 1 for the f graph, what is the limit? 1. So on the f graph, as x is approaching 1 from both sides, the y value is approaching 1, so the answer is going to be equal to 1. Let me go ahead and draw another example off to the side. I'm going to call this one f, and I'm going to call this one g. I'll say this value is at 4. What if we did the limit as x approaches 0 of f of x times g of x? We did a product one before. This is another product one, but I want to show you an example where this does not exist. Doesn't make as much difference to us. As x approaches 0, what is the limit of g of x? Right? It's going towards 4. It's going towards 0. They're not going towards the same number, so that limit doesn't exist. But what we really need to consider in this problem is what is the limit as x approaches 0 from the right? We have to think about it two-sided here of this same thing. So as I look at this one, 0 from the right, what is g approaching? 4. And 0 from the right, what is f approaching? So what's 0 times 4? 0. And if we look at the left-sided limit, so equals 0. If we look at the left-sided limit, the limit as x approaches 0 from the left of f of x times g of x. What is the limit of g from the left? 0. What's the limit of f from the left? 0. 0 times 0 is also equal to 0. So while you're thinking like, okay, so you have 0 times does not exist, it's a does not exist. Actually, what is the answer here? 0. It actually does exist at 0 because 0 times anything is still going to be 0. When we look at it from both sides, we can see why the answer would be 0 then. Okay, so we've done a lot of graph examples, some table examples. Here's our first function example.
So we probably did earlier, the f of h of x. So when you do the first part of the problem, it's as x is approaching to the one listed under, and when you solve the next one, the x approaching changes.
Yeah, like it's when you do the first one here, then you've used the limit. So we could say it's the limit as x approaches -2 of h of x, like this. And for -2, h is approaching the value of 1. So then I'd have f of 1. So I'm basically saying like the limit as f approaches 1, or just what is f of 1? Well, f of 1 is equal to 1. That's another way of thinking about like why like this value of 1 becomes like the lower bound for that, like what the limit is approaching. All right, so this one, this is about as direct of a limit problem as you can get. We've looked at some interesting graphing examples and table examples where like some weird things happen sometimes. What I really want to be able to do is just plug in the value and see what I get. So in this one, if we plug 1 in for x, 1 minus 11 is -10. Denominator 1 plus 7 is 8. And we can simplify that to say that this limit is equal to -5/4. We call this direct substitution because you're just plugging it right in and you're getting your answer right away. Like these are like the best to work on. If you can plug it in and get an answer, plug it in and get that answer then. What we're going to find in these next few examples is sometimes you get something weird going on. I like it when I get a straightforward number. But let's look at this one. Let's plug -4 in again. Numerator, -4 squared minus 15 is 1. And in the denominator, -4 squared is 16. 16 minus 16 is 0. We get 1 over 0. Now, if I try to do 1 over 0 on my calculator, what's it going to tell me? Error, does not exist. Can't divide by 0. So this has, I'll tell you, this has really 3 potential answers. What might the answers be? Could be undefined, does not exist. What else could it be? It could be 1. It might be 0. I'm thinking of 2 other things, though. It might not exist. What about, Eugene? Could be a hole in the graph. Now, is the hole going to affect the limit? The limit still might exist even with the hole there. And I'll tell you, actually, what's happening at this one, when you have something over 0, I'm glad you brought that up. What is actually happening there is you're getting one of those. You're getting an asymptote. So think about how graphs approach asymptotes. As this graph is coming from the left, where might it be going? Up or down? So what if it's going up? What would this limit be? Infinity. And at the other side, what if it was going down? What would that limit be? Negative infinity. If they were both going up, infinity. Both going down, negative infinity. But if they're going in opposite directions, that's when it would not exist. So that's what we're trying to figure out right now. Go ahead and get out your calculators. So in a calculus class, we would do some of this without a calculator. We wouldn't be terribly precise, like to get an actual number, but we look in the realm of something is really big, really small, divided by something else, and we have like a ballpark idea of what's going on as far as like, is this a really big number, a really small number? I'm going to go less than -4, like -3.9. So on your calculator, can you enter in -3.9 squared minus 15 over -3.9 squared minus 16. Plug in -3.9. I like to do the alpha y equals, choose n over d. That way you can tell clearly you have a numerator, you have a denominator in your fraction. It's a little bit easier to see. Well, then we'll get mine in there correctly. When you plug in negative 3.9, what did it come out to? Is it positive or negative? Here are a lot of different answers. Let me see if I can use my calculator correctly. So parenthesis negative 3.9 squared minus 15 in the numerator, and denominator parentheses negative 3.9 squared minus 16. So negative 0.2658. How can we get closer to negative 3 or to negative 4 from this side? Numbers that are slightly bigger than negative 4. How about negative 3.99? Try that one. Both of the x's. I got negative 11.5 something. Minus 15 on top, minus 16 on bottom. Okay, so these x values are getting closer to negative 4. Let's try it one more time. What's an x value even closer to negative 4? So we are approaching the x value of negative 4 from numbers that are slightly bigger than negative 4. And let's see what's happening with this trend of the y value. So plug in this, and let's look for the output this time. Is it another negative number, I'm assuming? Is it a bigger negative number? So as we get closer and closer from this side, what are these numbers trending towards? Smaller and smaller, bigger and bigger negatives. What would we call that? Negative infinity. Down, 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 right? So that is from one side. Let's look on the other side. Like negative 4.1, negative 4.01, negative 4.001. I could do all three of those again and go through that same progression. Or how about I get really close on the other side, like this negative 4.001, and see what's going on there. I have a feeling it's either going to be another positive or negative infinity, either a really big positive number or a really big negative number. Let's go and do the negative 4.001 because, again, I think this will tell us like probably what was happening here. There's going to be another trend where these are getting really big or really small. Victoria, do you have it? Positive 125? Okay, so now we're looking at a big positive number. My guess is if you did negative 4.00001, it's going to be even more positive number. What is it trending towards from this side then? Positive infinity. So at x equals negative 4, from the left, numbers that are even more negative or less than negative 4, we're going up. From numbers that are slightly bigger than negative 4, we're going down with that vertical asymptote. So what would you say this limit is equal to? I'm not going to put 1 over 0. The limit does not exist. The limit doesn't exist because from one side, the y values are getting really big, and the other side, the y values, the outputs are being very small. So when you get a number over 0, we're just going to analyze from both sides. Calculator is a fine way to do that. Just plug in numbers that are on both sides of what we're trying to evaluate the limit at and see where they're going, big or small. Next one. The limit as x approaches 2. So again, this is another function form. What I would prefer to do is just plug in the value, and hopefully I get a good answer. So if we plug in 2 for this one, we get 4 in the numerator, 0 in the denominator. Darn. Okay, so it's another one of those weird ones. There's 3 options. It could be infinity, or negative infinity, or it could be does not exist. At x equals 2, maybe both sides are going up and the answer would be infinity. Or maybe both sides are going down, it's negative infinity. Or maybe still one's going up, the other's going down. So if I call this function f of x, if I plug in 2, it does not exist. Can you figure out on both sides what's going on? So let's make a generalization here. At 1.99, you plugged it in, you got a value. From this left, do you think it's going up or down? Big positives or big negatives? Big negatives. So there's our trend from the left. As I get even closer, 1.999, I'm going to get even more negative. Whereas from the right, if you plug in like 2.01 or something slightly bigger than 2, what is this trend doing? Going up. So from the left, our limit was negative infinity. From the right, the limit was positive infinity. So what is this limit going to be? Does not exist again because they're going in different directions. If it only had like a 2 from the left or a 2 from the right, like a negative or a positive there, the one-sided limits both existed, or they'd be either infinity or negative infinity because they were different. That's why it does not exist. So when you get a number over 0, analyze. Look at the table. No, that's a good question. She said, will always be does not exist. So you might get some where it is, like if this was a limit as x approached 3, and I wanted to, maybe x squared minus 9 might be a better example. If I plugged 3 in for this one, I'd get 9 over 0. And then if I started analyzing, like at 3, it doesn't exist. But I looked on both sides. In this case, they would both, that can be true. Are they both going to go up? No, it'd look like this. X minus 3 squared. In this case, I think it's going to be positive infinity from both sides. So we actually could get an infinity. So if I start plugging like 3.01 in and 2.99 in, they're both going to give us going towards positive infinity. So sometimes you will get a does. It's not always going to be does not exist. Okay, so for this one, again, first thing you want to do when you see these problems is just plug it in. Plug in -1 for all the x's. 12 times -1 cubed. What is -1 cubed? Sorry, -1 times 12 is -12. -1 squared times 12 is 12. So -12 plus 12 in the numerator divided by -1 to the 4th minus -1 squared. We get 0 over 0, and this is different. It's not 5 over 0 or 1 over 0. It's 0 over 0. This is different. We don't go right into analyzing. This is called an indeterminate form. Anytime you get 0 over 0, it's indeterminate, which means there's something else to do before we start to analyze. So I don't really want to go into a bunch of tables and have to use my calculator if there's going to be a quicker way. And that's what we're going to do in this one. So because it's 0 over 0, we're going to do something else. Looking at what we have here, what do you think we're going to do to both the numerator and denominator? I'm hearing a lot of simplifying. Specifically, how about we factor? What can we factor out of the numerator? More than just x squared, 12x squared. And if we take that 12x squared out, then what would go inside the parentheses? Okay, so there is the numerator factored. Denominator, what's your GCF down there? And then inside the parentheses? So 0 over 0, it meant to do something else. In this case, that something else was to factor. And as you look at this, what can you simplify numerator to denominator? Get rid of them, both of them. Divide by x squared, divide by x squared. Limit as x approaches -1 of 12 over x plus 1. But in that denominator, we have x squared minus 1 still. And that should be a familiar one to us. How does that factor? So it's a difference of squares, x plus 1, x minus 1. X plus 1s are actually gone. So factor a little bit more. Now let's look at the direct substitution. If you plug -1 in now, the numerator is still 12. Denominator, -1 minus 1 is -2. 12 divided by -2 is -6. So what this tells me is the limit is -6. This graph, unlike these other ones where we got a vertical asymptote because it didn't cross off, we just have a hole in the graph. If x is -1, the function doesn't exist. Like we get a hole in the graph, but the limit from both sides is actually going to be -6. So something that's probably happening in this one is when x equals -1, from the left, it's going towards -6. From the right, it's going towards -6. That's why we're getting this limit. So why did we know to factor? Because it was 0 over 0. That meant to do something else. We factored, and we were able to actually plug it in and eventually get a nice answer. All right, we've got 2 more. This one, then we're going to start briefly on day 3. Here's our next one. Step 1, plug it in. So when you plug it in, you get 0 in the numerator. What's happening in the denominator? 0 as well. So indeterminate is the word we use for that. It means there's more work to do. However, I can't factor either the numerator or the denominator. They just don't factor. So we're going to have to do something else. And I know a lot of times people say, like, well, what should I do? How about if I square the numerator and denominator, which seems like a reasonable thing to do? There's a square root. If I squared something, then I could get rid of that square root in there. But consider this. If you have the fraction of 2 over 3, and you squared the numerator and squared the denominator, we'd get 4 over 9. Are those 2 fractions equal to each other? 2 over 3, is that bigger or less than 50%? It's bigger than 50%. What about 4 over 9? It's less than, right? 4 over 8 would have been 50%. 4 over 9 is less than 50% then. So these are not going to be equal to each other. We can't do that. You can't square the numerator and denominator because by squaring this, you're really multiplying the numerator by 2, and you're really multiplying the denominator by 3, and that's not allowed. We can multiply by 2 on top and bottom. We can multiply by 3 on top and bottom, but we can't multiply by different numbers, so no, we're not going to square. Instead, think of other things we've done when we've had a square root in the denominator. What's that thing called when we multiply by? Not really the reciprocal. Start with the letter C. Conjugate. You're close. Conjugate. Square root of x plus 5. What will come after this then? Plus 2. And we're going to multiply that in the top and bottom. Which looks like a mess initially. And in this second step, it's going to look like a mess again. But it does simplify down eventually. So limit as x approaches -1. And in the numerator, I'm not even going to bother trying to multiply by those by each other. I'm just going to keep it up in the top. There's no issue really in the top with having a square root initially, so leave it up there. The denominator, though, we expect some things to happen. beginning with multiplying those. Square root of x plus 5 times the square root of x plus 5. What's square root of 3 times square root of 3? What's the square root of 13 times the square root of 13? So what would be the square root of x plus 5 times the square root of x plus 5? X plus 5? Multiply these now. What do you get when you multiply the outside terms? What do we have to multiply next? And then lastly, so the negative 2 times the 2 gives us negative 4. And this looks like pretty horrible at this point, but look at the denominator. Do you see some things that are going to drop off and simplify? The positive 2 x root 5, the negative 2 x root x plus 5. So the worst parts are just gone now. That was the advantage of multiplying by that conjugate. And look at what's remaining down there. It says x plus 5 minus 4. So what are we going to write down there? It's just x plus 1. And remember, the numerator, we didn't even take the time to multiply out, because when you multiply by a conjugate like this, now those are gone, and there's no more denominator. The problem we had here wasn't that we got a 0, it's that we got 0 divided by 0. Now there is no more denominator to get a 0 in the denominator. So plug negative 1 into the numerator, plug it in for that x. Plug negative 1 in for that x. What does this equal then? 4. Negative 1 plus 5 is 4. The square root of 4 is 2. 2 plus 2, there's our 4. So when you get 0 over 0, factor or multiply by a conjugate, 2 good processes to use to be able to evaluate the limit. All right, I want to start on this 1 day 3 example, and then I'll give you time to work on the con problems. So here's our graph. This is the function g. The first question says, what is the limit as x, or says the limit as x approaches 1 from the left is equal to negative infinity. So on my graph, the limit as x approaches 1 from the left, is that equal to negative infinity? So here's x equals 1. As we're approaching it from the left, are these y values approaching negative infinity? No. What are they approaching? Positive infinity. So is this one true? No. So sorry, no. Next one says the limit as x approaches negative 5 from the right is equal to infinity. As x approaches negative 5 from the right, so here's my x values getting closer and closer to negative 5 from the right. Is that going up towards infinity? Yeah. So this one looks true. The direction said check all that apply. So letter C might be true also. If we check that one, it says the limit as x approaches 3 with no plus or minus, so it is a double-sided. The limit as x approaches 3 is equal to negative infinity. So as x is approaching 3 from this side, and as x is approaching 3 from the other side, are those y values getting closer? Or are they approaching some infinity? No. What do you think this limit would actually be equal to? Probably 3 or close to 3, maybe a little bit less than 3. But it definitely doesn't work, so not true. How about this one? It wasn't given to you. G of x. What is the limit as x approaches infinity for g of x? So as x goes further and further to the right, what are the y values approaching? 3. So even though we can't approach it from like the right and the left, we're just going from numbers that are smaller than it to the right, the y values keep getting closer and closer to 3.